Another short and fun C++ project, you say? Sure, let's get into it. This matrix effect is actually pretty interesting to build. But before anything starts falling, glowing, or flickering across the screen, we need one important thing. Manual control over every single cell in the console. Basically, we are creating our own tiny pixel display, made entirely out of text characters. So at the top, we include Windows Edge and IOStream, because this program relies on the Windows API to take over the console and draw at pixel, or technically character cell level. Next, we define the width and height of our screen buffer. In this case, it's 120 characters wide and 40 characters tall. That will give us enough room for a clean animation later. Then we declare a few important variables. A handle to the console window, a buffer that stores every character that will appear on screen, and some settings that control where and how the buffer is drawn. The first big function is called setup console. This is where the magic happens. We grab the console window using getSTDHandle, then manually resize it to fit exactly 120 by 40 characters. No scroll bars, no resizing, just the fixed frame for our animation. Then we set up the screen buffer. This buffer is basically a giant array of character data that represents the entire visible console. It stores both the characters itself and any visual attributes like color. We also make sure the cursor is hidden, because having a blinking cursor in the middle of a digital rain effect, that's not cool. Now, let's move to clear and draw. Right now, this function wipes the entire screen by replacing every cell in the buffer with a space. Once that's done, write console output A pushes the buffer to display in one single operation. This approach is important. Instead of printing character by character like a standard console app, we update the entire screen at once. Now, that's how we get smooth animation. Finally, in the main function, we call setup console once, then enter an infinite loop. Inside the loop, we clear the screen and then pause for 33 milliseconds. That gives us a steady refresh rate, about 30 frames per second. Right now, the program just draws a blank screen over and over, but this structure is essential. Now we are ready to animate something. Let's add our very first droplet, just a single falling symbol in the middle of the screen. So here we define a structure called droplet. Think of a droplet as one vertical stream, one column of 40 characters. Inside the struct, we store two things: y, which represents the droplet's vertical position on the screen, and speed, which controls how fast it falls. Then we create a single instance called drop. It's simple. Right now, just one droplet floating in space. It's time to actually initialize it. Inside setup console, we give it two starting values. Let's say -5 for drop y, which means the droplet starts just above the top of the screen, not visible yet, but ready to fall in. And then speed 0.7, a slow, steady descent. No rush, we want that smooth matrix motion. Next, we update our clear and draw to actually animate this droplet. We start the same way, by clearing the entire screen buffer so every frame begins fresh. Then we update the droplet's vertical position by adding its speed. If it goes past the bottom of the screen, we reset it back to the top, creating an endless loop. After that, we draw the head of the droplet. We convert the floating point position into an integer now, calculate the correct index in the buffer, and place a single character, in this case a bright green star, right in the center column. Finally, write console output A sends everything to the screen at once, giving us smooth movement. We've gone from a black console to our first falling symbol. Now that we've proven that animation works with a single droplet, it's time to scale things up. The first change is simple. Instead of one droplet object, we switch to vector droplet. This gives us a space to store as many falling streams as we want. Next, inside setup console, we replace the old initialization with something much more dynamic. We resize the vector so it holds one droplet for every column on the screen, meaning each vertical line will eventually get its own falling stream. Then, for each droplet, we randomize the starting position somewhere above the screen, and we also randomize its falling speed, somewhere between slow and slightly faster. This randomness makes the animation feel alive instead of robotic or synchronized. Finally, we update clear and draw. Instead of moving and drawing just one droplet, we loop through all of them. Each one falls at its own speed. If a droplet reaches the bottom, we reset it to a random position above the top, so the animation never ends. Then we convert the current position to an index in the buffer and draw a bright green star at the droplet's X position. By the time the frame is rendered, we no longer have 1 pixel falling. We have a full storm of digital rain. Now we are getting somewhere. The animation finally looks like falling rain, but it's still missing that signature matrix look. In the real matrix effect, each stream isn't just a single point. It has a glowing bright white head, followed by the trail of fading green symbols. So the next step is giving each droplet a length and drawing every segment from the head all the way down its tail. For this iteration, we add one more field to our droplet struct, length. This tells us how long each falling stream should be. Some will be short, others long, just like the chaotic pattern in the movie. Then, inside Setup console, we initialize that length with a random value, so every droplet feels unique. Now we update the drawing logic inside Clear and Draw. Instead of drawing just the head, we look backward from the head position to draw the entire trail. For each position, we set the character and apply different brightness levels. The very first symbol, the head, gets a bright white glow. The next couple of symbols stay bright neon green. Everything behind it gradually fades into darker green. This gradient is what gives the illusion of motion, like a glowing stream dissolving behind itself as it falls. And once this part is running, the effect suddenly jumps from falling text to recognizably matrix. But we are not done yet. It looks great, but there's still something missing. In the movie, the rain isn't static. Characters flicker, mutate, glitch, constantly cycling through symbols like corrupted data. So, in the next step, we add randomized characters. First, we create a helper function called getRandomChar. This function picks a random symbol, sometimes a number, sometimes a letter, sometimes a random punctuation mark. Then, inside the drawing loop, instead of just printing the same star character, we assign characters dynamically. Some characters stay the same for a moment, others randomly change. That tiny bit of chaos makes the animation feel alive, almost organic. With this change, the effect finally captures that iconic matrix vibe. Glowing trails, wide leading characters, and unpredictable flickering symbols. The code is still simple, but now it looks, dare I say, cinematic. And just like that, we reach the full matrix rain. We built this effect step by step, adding one idea at a time. First, we took control of the console buffer. Then, we animated a single falling droplet. Next, we expanded it across every column. Then came the trailing effect, the glowing gradient, and finally the flickering characters that make it feel alive and unpredictable. What started as a blank window has now turned into a living stream of cascading digital rain. And it's really the mindset to take into any project. One small step at a time. Build, test, improve, repeat. Don't stress about finishing everything at once. If you try to picture the entire final result from the very beginning, it's easy to get overwhelmed and stop before you even start. But if you approach it in small, manageable iterations, each step feels achievable. And before you know it, you are looking at something you are proud of. If you made it this far, awesome job. You can expand this even further. You could add things like variable fading, Unicode symbols, brightness decay, or even 3D style layering. There's a ton of room to play. And that's it for today. Thanks so much for watching. If you enjoyed this and want to see more in the future, don't forget to hit the subscribe button. See you next time.